write the equation of the ellipse that has center negative 2, 1, a focus at negative 6, 1, and a vertex at negative 7, 1. Okay, so this is a good question. So let's begin by, we really need to graph the thing. So let me come down here and make an axis, a graph of this thing. Okay, so first let's locate the points. The center is minus 2, 1. So there we go. There is minus 2, 1. Back 2, up 1. And then the next point, the focus is minus 6, 1. 3, 4, 5, 6, right here. This is minus 6. So this is the point minus 6, 1. And this is a focus point. And then finally, it has a vertex point at minus 7, 1. Right here. So this is a vertex, and this minus 6, 1 is a focal point. Now, remember how these things work. This ellipse must be sitting somewhere like this. How do I know it's wider? Well, if the focal points are sideways, then the ellipse is wider than it is tall. If the focal points are up and down, then the ellipse is taller than it is wide. The focal points, let me remind you of this, the focal points always sit on the major axis, the biggest axis. So if if it's the bigger direction, the major, the bigger direction. So if the graph is wider, the focus points go sideways. If it's taller, it goes up and down. Well, on this one, we know this graph must be wider. Why? How do I know? Because here's the center right here, and the focal point is to the left of it. So the focal points are left and right, which means I must have a graph like this. So let's find the other focal point. How far from the center to the focus point? 1, 2, 3, 4. So it's got to be 4 the other direction. It's always they always have the center right in the middle of the two focus points, and it's right in the middle of the two edge points. So I'm going to go 4 the other direction. 1, 2, 3, 4. There's got to be the other focal point. And then one more beyond that has got to be the other vertex, doesn't it? Because everything's symmetric here. So this has to be the other vertex point. So, okay, so that means generally this ellipse looks like this. I don't really know how tall it is right now, but I just want to draw something so I can take a good look at it. So there's what I know so far. Okay, now we know that the equation is x and y, these are, squared. And we know there's a 1 over here. They always have a 1, these ellipse equations. So do we know what's next to x and y? Yeah, it's always the opposite. So this would be plus 2 because the opposite of it is the center minus 2, and this must be minus 1 because the opposite of it is plus 1 for the center. Minus 2 and plus 1, the opposite go next to x and y in the parentheses, always the opposite. Okay, that's the center. So now what goes underneath x and underneath y? Well, whatever's underneath x is how far right and left. And that must be 5 squared, right? Because from the center to the edge, it's 1, 2, 3, 4, 5. From the center. You could go left or right. It doesn't matter. 1, 2, 3, 4, 5. It's back 5 or right 5. Either way, it's 5. So a squared must be equal to 5 squared. So all I've got left to find is b squared. And I don't really know what b squared is. What can I do? Well, I do know where the focus points are, so I can use the focal equation. We don't use that very often, but it is important. So what's the focal equation? It says, it's like the Pythagorean theorem, a squared plus b squared is c squared, except it has minus in the middle. So it's basically the Pythag with a minus. Now, what are a and b, and what are c? C is the distance from the center to the focus, either focus point, it doesn't matter. A and B are distance center to the edge, and A is the bigger one. Remember, whenever we use that equation, A is the bigger one. So A and B are how far distance from the center to the edges. C is the distance from the center to the focus points. So do we know C? Let's start with C. How far from the center, here's the center, to the focal point, here's the focal point. Let me get rid of what we did down here. Oops. Okay, so how far from the center, here's the center, to the focus point, which is right here. See the focus point right there and the center right there. How far is that? 1, 2, 3, 4. That's 4. So C is 4, isn't it? And what A and B are how far from the center to the edge. So we've already done that once. We do that again. From the center to the edge. Oops. From the center to the edge. From the center to the edge. This is 1, 2, 3, 4, 5. So this must be 5. And by the way, I do know that is A because that's the bigger direction. This ellipse is wider than it is tall. Now, if the ellipse was taller than it is wide, then A would have to be the up and down because, again, A is the bigger. It's the bigger direction to the edge. A and B are the distance from the center to the edges, where A is the bigger direction. So in this case, A is right left. It's how far from the center to the edge, which is 5, and C is how far from the center to the focus, which is 4. And now we can solve this equation for B. So this is going to be 25 minus b squared is 16. Subtract 25 from both sides. Minus b squared is minus 9. And now divide by minus 1. So bring it over here. B squared is plus 9. And then root it. B is 3. So B is 3. So we finished our work for our equation. We'll bring the equation down to here. So coming on down, this will be x plus 2 squared over 5 squared, 25, plus y minus 1 squared over b squared. B is 3, so this is 3 squared. We'll just make it 9 equals 1. So there is our equation. Or I should have actually just put the 3 squared right here. And get rid of this here and just let it be 9. Whoops. There we go. So that's a lot of work. So the trick was identifying A, B, and C.